Hello and welcome to the Edupedia world. Within this tutorial, we are going to try some program of creating a single linked list, and let's try some practical example of single linked list using Java. You can try doing the same example in other languages, whatever you like. So let's open our Eclipse Studio and try to do example of single linked list in Java. Okay guys, so I have already written a demo program. Let's do a walkthrough of this program. So I'm having a class node. Inside my class node, I have taken int element. So this is actually the node that I'm forming. So this node class will actually form the individual node of linked list. Now this element could be of an integer type or it could be of a specific type, let's say object type or any generic type. So you can create this node of any type. For simplicity, I have included it as an int type. Then it's having a next. So next is actually pointing towards the next node associated in a linked list. So this node is actually pointing towards the next node. Alright. After int element, I have included node next. Then I have created a constructor which is taking my element and it is storing the element, and this constructor is making next to point towards null. Alright. After that, I have created getters and setters for get element, set element, and get next and set next. Alright, so this is my node class. Now let's do a walkthrough of our linked list class. So now linked list class is my actual class where I have written methods to do the traversing, insertion, and deletion. So this is my linked list demo, and inside this you can see I'm having a private node head. So the initial node that I'm creating is head in my linked list. And then I'm also maintaining a counter. Now this counter is optional. You may want to use it or you can simply comment it out if you don't want to use it. If you don't want to maintain a count of your linked list, if you don't have to somewhere show the size of a linked list, then you can even skip this step. But it might be needed that we want to somewhere know the size of linked list. That's why I have kept the list count. Now firstly, let's go to a traverse method. So let me open the traverse method. Okay, this is a traverse method. You can see in the traverse method I have included two cases. One is when our list is empty. So therefore, I am actually checking if my head is equals to null, then it will print empty list. That means your linked list is empty, so your head is empty. Alright. The second case is if your head is not empty, then it will go to the else block. Let's say if I am having some of a node. Then what it is doing is, it is taking node current equals to head. So we have taken a current node and we have made it point towards the head. And then we are doing while current is not equals to null. That means our current node doesn't become null. Till then, it is printing the element of current and doing current equals to current dot get next. I hope so you are able to relate it with the pseudocode that we have written in our previous module. We were doing a similar thing. We were taking a temp. Instead of temp, I have used current over here. So CURR is my current node. It is actually pointing towards the current node. So initially I made it to point towards head, then I am traversing it by doing current equals to current dot next till my current becomes null. So till my current is not null, it will keep on traversing and printing the values. So this is a traverse method of a linked list. Now let me show you another method which is find. Find method is also very similar to traverse method, but in this method you have to actually find a particular element from a linked list. So instead of traversing till the last element, just put a loop to traverse till the last element, but inside that we check a if condition. If your current element, get element, is equal to the element that you want to search, it has to print that position on element and break over there. Okay, so that we don't unnecessarily traverse through the whole linked list once we have found an element. So you can see the similar condition we have checked if head equals to null, then print empty list. Alright. That means if your list is empty, your head is equals to null, then it will print it's an empty list. Otherwise, what it's doing is, It's taking current and it is pointing towards head. Then it is also taking a index equals to 0. Alright. Then inside a do while loop, what we are doing is we are checking if the current element dot get element is equals to value. That means the current element is equals to the element that you are searching. Then print that value, like print that index on which index it is found and break from the loop. Otherwise, it will keep on doing current equals to current dot get next. Okay. And like whenever this loop exists, it will exist when currents dot get next will become equals to null. That means there is no further element to traverse when we have reached to an element where currents next is equals to null. Alright, so this is a find method. I hope so it's very simple and it's clear to you that how we are able to find the element in a linked list. Alright, now let's go to the method insert. Okay, so let me go to the insert last first. So insert last will allow you to insert the element in a linked list at last. That means whatever the last node is, your new node will be inserted after that last node. Okay, so let's see how it is working. So let me just, yeah, now I think it's fine. So we have taken insert last, in that I am taking a value. And you can see that I have created a new node which is node. I am given it a name as node and passed it a value. So I have created a node which I want to insert. Alright. Then I am checked if head is equals to null. That means currently my no other node has been inserted in a linked list. That means I am inserting the first node. So in that scenario head would be null. Alright. Then I am making head to points towards the node. That means if head is pointing towards a node, that means I have inserted my first node and head is pointing towards my new node. Alright. Otherwise, let's say if my linked list is already having some node, then I'm actually taking a current node and I'm making it point towards head. Then while current dot get next is not equals to null, that means I haven't reached to a position where I don't have any further element. So then I keep on traversing towards a linked list. Okay. So I keep on doing current equals to current dot get next. So that means current will become current's next. So whatever next element is there, current will start pointing towards that. Alright, so it will keep on doing that till it has reached to a point where there is no next element. That means where current dot get next is not equal to null, so it will start doing that. Once it has reached to that position, it will come out of a loop and it will do current dot set next equals to null. That means at the end it will make current's next point towards a new node that I have created. Alright. So this is my insert last logic, and in the end I'm just increasing a count to just keep a track of number of elements I have inserted. Alright. So this is insert last method. I hope so it's quite clear. It's very simple. Once you understand the pseudocode and you have gone through the previous modules, I think you'll be able to get it very easily. Now let me go to insert after method. So this is my insert after method. Inside insert after method, I'm actually taking the value that I want to, like this value over here is, let me change it to, okay. So I have changed the name of variable and I have made the name of variable as insert after it so that it's clear to you that this is that variable or that value after which we want to insert. Alright, and this element is something that we want to insert. So what I have done is I have created a new node. I have done node equals to new node, and in that I have taken this element so that this new node is created. After that I am doing if head double equals to null, that means it is my first node that I am inserting, then it will make head to point towards that node. That means this node that I am inserting is actually my first node. So this will make my current node to point towards that node. Alright. My head will become the first node and my the element that I want to insert will be inserted as a first node and head will point towards it. Okay. Now let's say that was not the case. If head is not equal to null, then what will happen? Then again I'm taking a current and current is pointing towards head. Alright, as per this line. Then I'm traversing current till current's next is not equals to null. That means there is no further element to traverse. Alright, and then I'm checking if current dot get element is equal to insert after it. Means it is equal to the element that I want to insert after it. Let's say I want to, like our case when we were having 1, 2, 3, 4, I want to insert 5 after 2. So is current dot get element is equals to 2. It's actually checking that. Is it that element after which I want to insert? If yes, then what it is doing is, it is making node set next is equals to current get next. So it is making your node that you want to insert its next to point towards current next. Alright. So I wish to show you again. Okay, alright, let me just remove all this. Alright, so now let's say if I want to insert something after 3 and I have reached, let me change the name of this variable to current. So now I have reached my current over here. What I am making is, I want to insert something over here, right? So what I am making is, this is my new node that I have created. Now this is my new node and this node actually contains 5. So I am making my nodes, right? This is my node. So if you just go back to the code, I am making node dot set next is equals to current dot get next. So I'm actually setting the nodes next is equals to current dot next. And what is current dot next? Current dot next is this. So I'm making this to point towards this. Alright. And after that, I'm making current dot set next is equal to node. That means current next. Current next is this. So I'm making current next to point towards node. That means this will point over here and this link will be broken. So in this way, we have actually inserted a new node over here. Alright. And after that, once I have inserted, I'll do break so that, let's say if I'm having 5 more elements further, so that means I'm making it to point towards this and I don't want to traverse any further because I have already inserted my node, so it's break from the loop. Alright, so this is if condition, and let's say if you're this condition is not fulfilled, then till then keep on doing current equals to current dot next so that we keep on traversing and finally we can reach to a particular element where we have to insert. And it could be a case that we haven't found the element. In that case, this loop will completely run till the last element and that element won't be available. Alright. So instead of making this count as over here, let me write it over here because I only want to increase the counter when I'm inserting something. It might be possible that this insert after it is not actually present in the linked list, so I don't want to increase my list count in that way. Alright, so this was a method insert after. Alright, now let's see another method. This is insert before method. Okay. So as I've told you, insert before is very similar to insert after. The only difference is that you have to stop one position before where you have to insert. So in insert after, we used to stop at the element that we are searching. So let me make it again. We need to insert before it. This element is something where we have to insert before. So instead of making it to stop, at a particular element that we want to, I would say, delete or, where I have to insert, let's stop somewhat before it. Okay. So that is one approach of doing that. Now let's see how I'm doing in this code. Over here, again, this is for the first node. I hope so this is very clear by now. Like we have initialized a node, then we have checked if it's the first node, then we have inserted it. Otherwise, we have taken a current. Okay, it's pointing towards head, and then we have taken a previous. So in a pseudocode, we have seen one approach where we are stopping one element before the element we want to insert. In this approach, this is another approach that you can follow. In this approach, we are taking two nodes. One is to point towards current and one is to point towards previous. That is, it will move just one node before the current node. Okay. Previous is pointing towards null and current is pointing towards head. Then we have taken while current dot get next is not equals to null, alright, till the last element is not reached. But then we are like running this loop, and inside that we are having a if condition where we are checking if current dot get element is equal to insert before it. Alright, if it is equals to the element that we are searching, then do something. If it is not, then keep on making previous is equal to current and current equals to current dot get next. So each time your previous will become current and current will become its next element. So in a way, like if I just show you diagrammatically, so alright, let's say I want to like insert something before 3. Alright, so I have taken a previous and current. So that means initially my previous is pointing towards null. Alright, this is null and my current is pointing towards head. Now inside a while loop, what I am doing is I am making current to point to currents next, and before that I am making previous to point towards current. So if my previous is pointing towards current, that means my previous is pointing towards current, which is this, and my current is pointing towards current next. And what is current next? It is this. Alright. So here is the current. Now we keep on doing that till we reaches the end or till the if condition becomes true. And what is the if condition? If condition is if current element, current dot get element is equal to insert before it. For our case, insert before it is 3. So now again run the loop and I'll make previous to point towards current. So previous will point towards this and current will point towards current next. Alright. So now current is pointing towards current next and previous is pointing towards current. Alright, now again if we check for the if condition, and it can see that current dot get element is actually equals to the element we want to insert before, which is 3. So in this case the if condition has become 2. Now what's happening in the if condition? It is going to check if current is equals to the head. Alright. Okay, so once we've reached here, let's go back to our if clause and see. Okay, ideally what we need to do is we need to make previous next. Alright, so this is like we have to insert before it, right? So I'll be having some new node. Alright, so this is my new node. Let's say I want to insert 5 over here. So I have to make previous next, which is this. Okay. I need to make it to point towards my new node. But before that, I don't have to my current is pointing towards this. Okay, so what I want to do is I want to make its next to point towards my current. Current is pointing towards this, so I'm making my new nodes next to point towards current, and I'm making previous next to point towards my new node. Alright, so in this way, this link will be formed and this link will be broken. So in this way, my new element has been inserted in a linked list. So if I go back, I can see I'm doing exactly the same. I'm making node set next is equal to previous dot get next. So previous dot get next was this, or I can say simply current. So it will point towards that, and then I would make the previous next is pointing towards node and break from the loop. Alright. So this is one way of doing that. Another way was something we have seen before where we were not taking previous, but we were stopping just before the current element and we were keeping a track of the previous in that way. So you can choose any of the two approach, whichever you find better. As far as I am concerned, I think it's better if we don't keep previous separately, because in that case you are saving some of our memory and you are able to keep a track of it by simply having one element current and just stopping it away before the current element. So instead of making current to points towards 3, let's stop current to towards 2 only and do the operation by using currents next. Whatever we were earlier doing using current, instead of using current over there, we'll use current next. Okay. Alright guys, so this was insert before. Again, I need to make this change of putting a list count over here. Alright. Now we have seen insert after, insert before, insert last, traverse, find. So the function that I'm left with is delete. Okay, now let's go back to the delete and see how delete is working. Okay guys, so this is delete method. Inside a delete method, you can see firstly we have to find the element that we want to delete. So for that you might try to use the find method which you have already written, or you can write the same functionality yourself. So I have written the same functionality myself where I am using if head is equals to null, that means I am having an empty list. So therefore I will print the list is empty. Otherwise what I am doing is I am taking a current node which is pointing towards head. Again I am taking a previous node. Then I am taking an index equals to 0. And I am checking while my current is not equals to null, it will make previous to point towards current and current to point towards current's next. And then it will also check if current.get element is equals to value, then it will do previous dot set next equals to current.get next. Okay, let me keep if above it because I don't want to skip the first current. Otherwise, in that case, the first current would get skipped. Alright. So now my first current will also be taken care of. I'm doing current.get element is equals to value. That means I'm actually checking whether my current element is actually the value that I'm searching for. I want to delete. If yes, then I make simply my previous next to point towards current next. So we have already seen it diagrammatically how we were doing. So we are doing exactly the same thing in the code. So we are just taking our previous next to point towards current next. Alright. And then I'm just, like if this condition is not true, then it will keep on making previous and current to traverse ahead. Alright. So this is a delete case. Alright guys. I'm having one more method over here which is reverse. But I want to show you how reverse work in a different module because this will take a good amount of understanding. So that's why we'll cover reverse in the next module. Okay guys, thank you so much for attending this module of linked list. Now we have to cover the doubly linked list in our next tutorial. So I'll be sharing you what is doubly linked list. I'll be also telling you what is circular linked list in our next tutorial. So stay tuned. Thank you.